Hello, and welcome back to Network Decode's Nautobot Navigator series. My name is Tim Shryak, and I will be your guide as we navigate the complexities of network automation. Whether you're a network engineer or an automation enthusiast, this second video in this series will get you started towards great success with Nautobot. Please do feel free to follow along with me in the public Nautobot Sandbox at demo.nautobot.com. The link is also located on the screen and in the description. You can log in using the username and password located right above the login box. In the first video in the Nautobot Navigator video series, we covered viewing and populating devices and modeling your organization. This video focuses on the next key step, viewing and populating the IPAM data model. By populating Nautobot with basic information about the network and defining the intended state of your network, you're laying the foundation for building world-class automations. So glad you're here, and I can't wait to show you around. Let's start navigating. So here we are at the main screen of Network Decode's demo.nautobot.com, our public sandbox. Please feel free to follow along with me. As you can see, their credentials are right here up at the top, as I mentioned earlier. So let's get logged in. Today, we are going to be highlighting the IPAM functionality of Nautobot, and you'll notice that over here on the left-hand side of the screen, the IPAM section. So let's drill in. First, we'll start off on IP addresses and just start at the basic information here. And you may notice when you first come in, especially into the public sandbox, you may see some limited information, and you may be wondering, where is the rest? And that is simply because perhaps someone else was using the public sandbox and they changed the view that you might see here. You can easily adjust this. So we can just go to configure. We can select all of the columns that we want to see, hit save, and Nautobot will then refresh the screen for us. And now we will see all the available information available to us under the IP address section. So here we go. Now we have what we were looking for, something that we might have expected. Right? So let's just kind of look through the basic column information that we have available to us, starting off with the pointer record, right? The reverse lookup, the status. We might want to set the status of a particular subnet or host level address to active or maybe planning or perhaps inactive. There are lots of options of how you might use the status field. Very flexible here for you. And this is generally throughout Nautobot as well. You can use this status field on almost any object in the database. Perhaps assigning a role. Here we don't have some examples of that, but these are applicable in your environment, perhaps, depending on how you use IPAM. You may or may not wish to use the role field. Of course, the IP address itself, here in this case, and then the type, right? In this case, we're looking at hosts. We're not looking at subnets or supernets. You can use the tenant as a way in which you can assign particular IP ranges to particular, multi-tenancy concepts, whether those are perhaps business units in your business or just tenants, whatever makes sense for you. If you don't need it, don't use it. As you can see here, an example, it's left empty, right, in this particular example. Of course, then we finally have our DNS name, options for descriptions. This can be useful, essentially notes that you may wish to add. And now into namespace. Namespace is a really interesting topic. We're going to dive into this in a minute, so I'm just going to gloss over this here. But generally speaking, namespaces are the way in which we are able to make our IP addresses unique or not in the database. Interfaces. What interfaces are these IP addresses or IP subnets assigned to within the Nautobot database? Number of devices that are consuming this IP. Perhaps if you had any VMs or virtual machines, similar concepts here, right? So basically, where is this IP used within Nautobot? Virtual NATs. So if we had any NAT going on, we can document that here as well. Is it assigned? Essentially, is it in use on a device or an interface within Nautobot? You can see here's an example of one that is not, right? It's not assigned to anything, and therefore we don't have that checkbox ticked off here. And then finally, tags. Tags are a great option for a way in which you can make something easily looked up in the rest of either your automations or within Nautobot. Tags are very flexible. They give you a lot of power, but they do come with great responsibility. Tags are simultaneously the greatest thing in the world and the worst thing in the world, right? Because you can make a tag anything you want. That is both amazing and terrible. So you have to use them very carefully and strategically and think about how you're going to use your tags in such a way that you don't create a very difficult management nightmare as you move forward. Okay, so let's go into a particular address and start kind of looking at the details. So here we see the address name. We're looking at what its purpose is here. In the namespace, it's assigned to global. And we see the address expressed in the CIDR notation, right? So we have the /32 here indicating this is a host level address, which is a bit unusual here in this demo example of 10.0.0.0/32, but it is technically possible. So here we see that, and all of those details we were looking at in the earlier fields, we also see described here in detail for us. Now, as we go into the idea of the namespace, here we see it's assigned to global. Namespaces are used to designate boundaries of uniqueness. Duplication within a namespace is not allowed. So use cases for multiple namespaces may include acquisitions or mergers, or a managed service provider with multiple customers and overlapping private IP space. So anytime you have overlapping IP space, this is when you're going to use namespaces as a way to distinguish those overlapping IPs and make them unique. An IP address record can be used in multiple locations within your network, as in the case of VRFs, or virtual IPs is another example, in which case you might need to use namespace because you're reusing IPs within your network. If your network is relatively straightforward, you don't have any overlapping IPs, a single namespace will be fine. And you could just do something like global or default or main, whatever you want to call it. Namespaces exist to allow for exceptions to the restrictions that we might have otherwise on overlapping IPs within Nautobot, or generally speaking. Address types. As we highlighted on the earlier screen, here we have a host level address type. It's used to indicate function of an IP address. It could be host in this example. It could be a DHCP, perhaps. So you have lots of options on what you might have here under address type. The address status. Now, of course, we see here this particular one is active and in use, but we could set it as reserved. We could set it as depreciated. Really, it's quite flexible in how you might set your status. What makes sense in your environment? And roles. Again, as we see here, this particular address does not have a role assigned to it, but we can use roles to indicate special attributes of an IP address. Perhaps you might want to set the role as loopback, or as a VIP. Maybe it's an IP address used on a load balancer and it's your VIP. Or for redundancy, high availability, an HA pair. Maybe you want to indicate that in your role here. So this is a way that you can take your IP addresses and help you categorize them or abstract their functionality in your network into a higher level concept. Now let's look at assigning IP addresses. If we were to go, say, create a new IP. So let's start here. We're here on the IP address screen, and we have the handy add button right there for us. So let's go ahead and click that and drill into creating a new IP address. So we're going to add our IP, and we are going to spell this out with our CIDR notation. So that's 192.168.0.1/24. IP addresses do require a parent prefix, right? So if we're coming in here and we're creating a host level, we need to specify our parent prefix as well. We are also going to assign our namespace. Here we're going to say it's global of type host. We're going to set the status as reserved. We're setting this up for the future. We don't need a role on this particular IP, and we don't have a DNS name perhaps set for this. We're just making sure that we have this IP reserved out in our network. So now let's say that we wanted to create an IP address record. Maybe we're adding in some new functionality in our network, and we want to make some reservations in our IPAM. So we're going to go into our prefixes. We're going to locate the prefix for which we want to add our host level address, and we're going to go into it and then add that IP there under the prefix. So let's get into our prefix section here within Nautobot. And let's say that we're going to add a new address in some private IP space on our network on the 168.0.0 subnet. Now you'll notice here I'm using the search function to quickly go to that subnet so I can work on it more easily. However it makes sense for you and your environment to get there, all is good. Right? So here you can see I did create this earlier, this subnet that we're using out on our network, and it's part of our global namespace. And if we take a look, currently we don't have any child IP addresses here assigned. So let's go ahead and add one. You see here we have this add an IP address. We click there, and we're going to add, as Nautobot conveniently gives us, the next one available on the subnet. Right? So here we have 192.168.0.1 in the /24 subnet. It's going to be part of the global namespace because the parent prefix is, you can't change that here as you can see, and it's going to be of type host. This we could adjust, depending on what we might need this particular address to be. And we'll set its status to, let's say, reserved, because we're just planning for the future. Now we can go ahead and scroll down to the bottom and click create. And now we've created a new host level address under our parent prefix. And if we were to navigate around, you could see here, we could start off, let's say, at our global namespace, which would take us back all the way to the beginning. We could see those prefixes assigned there as well within the Nautobot IPAM section. So that is creating a new IP address within a particular subnet. Okay, so after that brief overview of the IP address section within Nautobot's IPAM, let's take a look at creating one. Maybe we need to add a new reservation that we're building some environment in our network, and we need to create some IP address reservations for that work. So first, we're going to go to our prefix section within Nautobot to get into the parent prefixes in which we're going to create this host level IP. So we're going to go over to the prefix section and drill into the particular prefix where we want to create this IP address. So let's say we're going into the 192.168.0.0 subnet. And this is where we're going to be adding our new host level address. So here we can see the high level information about this subnet. It is part of the global namespace, and it's of type network. And we're going to add a new IP address within there. And you can see we've already got one assigned out, 0.1/24. And let's say we need another one. So we're going to click the add an IP address. And you can see Nautobot automatically gives us the next available. Of course, you can change this if you want. But here, let's just say we want the .2 address in the /24 subnet. It's going to be part of the global namespace because the parent prefix is, you cannot change this. And we have some options on the type. We can set it to host, DHCP, or SLACC. Status, let's say it's going to be reserved. We're just setting this up for the future. We want to make sure this IP is reserved for future use. And so we just go ahead and click create. And that's it. We now have created our host level address here within Nautobot's IPAM section. Okay, now that we've created a single host level IP address, let's take a look at how we might do this in bulk. It's pretty common when you're building a new environment, you need to create reservations for lots of IPs, not just a single one. And doing that through the UI could get really tedious. So there is a way to do this en masse. We can do many all at once. We would simply go up here to the IP address assignments section within the Nautobot menu. And here we have the option to create or upload IP addresses via CSV. So you can see here, the only required field is the IP address, but of course you can specify additional fields here as we scroll down and we look at the documentation of the CSV field options. So here, all the things that you might specify in your CSV file are here available for you as we create these to help populate into the database. Now let's drill further back into prefixes. We did briefly go over this as we created a single IP, but let's go back over to prefixes and look at them in more detail. So once we get into the prefix section, we're going to take a look at the options that we have available to us, as well as the columns that are listed out. Similar to what we saw over under the IP address section, where we're looking at host levels, now we're looking at our subnets. Here we see the prefix specified with its CIDR notation, the namespace that it belongs to or has been assigned to, the type of prefix. So that is, it's a network, it's a container. You have different options that we might specify here under the type. Status again, this is very similar to what we saw for the hosts. And then the number of children that have been assigned out. Here you can see on some of these subnets, we have lots of children assigned, and you get that utilization report for you as well. How full is this particular subnet? And here you can see we've got 100% full in this particular subnet here that's assigned out to our tenant of Nautobot Airports as we are taking over the world with Nautobot. Of course, you can use tenant or not, just as we mentioned earlier. That's completely optional field for you, available if you need it. And then our location field, similar as what we saw earlier, assigning out locations to where this particular prefix is in use. And then optionally attaching to a VLAN. This is a really common thing that we do as we have our layer 3 networks. We're attaching them to particular VLANs, and so we can specify that here. And role, of course, here assigned out at the subnet level. And finally, description that we have available here. Now, there are additional columns that are available to you as you look at prefixes. And again, just like when we were looking over at the IP addresses, you would simply click configure and select the additional columns that you might wish to look at when you're viewing this here. So let's just say we go ahead and select all, and we can see all the columns available to us under the prefix section. Here we can see all of those columns now available for us, the additional options, things like tags, the allocation date, maybe it's assigned to a circuit. So all of these different columns that we might have as we use our IP address space and prefixes within Nautobot's IPAM. Now, to go a little bit deeper into some of these options that we have set on prefixes, let's take a look at this particular /24 address and go into some of the specifics. So namespace. The namespace of a subnet must belong, each prefix must belong to a particular namespace. This is not optional. This is a required field. So we can have some sort of default like global, makes sense, but you may create others as is applicable in your environment. So the location field, this one's optional. You do not have to use this. It simply allows you to document where particular IP addresses are being used in your environment and can be very useful, particularly when you have overlapping IP space. The assigned VRFs, the VRFs. This is an optional field. You do not have to use this if you're not using VRFs in your environment, or if you simply don't want to document them, but they are here available for you. If you do not specify one, the default is going to be the global VRF essentially. Now the type field. Here we're seeing an example of a type of network. This does make an adjustment to how utilization is calculated and the behavior of IPAM. So this is an important field. If it's set to a pool, every IP address within that pool is available and assignable, and valid parent type for that subnet would be a network. So this is where you say, hey, I'm going to specify my network as a /24, let's say, for example, and I want to create a particular pool within that /24 available for maybe DHCP, for example. That means from the very first IP to the very last IP, they're all available for use if they're assigned as a pool. If it's assigned as a network, then of course, the first and last IP addresses are not usable because it is a network, it's a prefix. Valid parent types for a network would be a container. Now, a container serves as a parent for pools and networks, and valid parent types for containers are other containers. So you can think of containers as a way in which you can group both networks and pools. Status, as we talked about earlier, defines this prefix's operational state. Is it active? Is it in planning? Is it reserved, etc.? And of course, role, as we mentioned earlier, our prefixes function. Here we're saying this is our server network. This is where we're assigning our servers out of. Now, let's go ahead and create a new prefix. So we're going to come in and we're going to say, hey, let's add a new prefix. Perhaps we need a 10.128.0.0/16, always CIDR notation within Nautobot. The namespace is going to be global, and we're going to set the status as reserved. We're planning this for the future. And type of network. Actually, you know what? Let's do type of container. And maybe that'll be more interesting as we go through here on the story. So we're going to go ahead and save this or create this here within Nautobot. And now we've created our container prefix of 10.128.0.0/16. And now we're saying, hey, okay, that's great. We created our container. And now we want to go ahead and add the actual network that we're going to use within that container space. So we're going to add another prefix. And in this case, we're going to say it's 10.128.1.0, and it's going to be a /24 coming out of that larger /16. It's going to be in the global namespace, of course. The type is going to be network, and we're going to set this to reserved as well as we're planning for the future. So now when we create this network or this prefix, it is going to become a child within the larger container of 10.128.0.0/16. And in fact, we can even see that specified over here on the left, on the right. And this container, as you notice, is actually a child of the larger 10.0.0/8 space. So you can see how we're assigning out and creating this hierarchical tree of IP addresses and our prefixes within our environment. So now that we've gone over the IP address section of IPAM, let's take a look at the VLAN section, the next logical operations within IPAM, or layer 2 functionality within IPAM. So as we just drill into our VLANs here within Nautobot, let's see what we have as some examples. Here we see, our VLAN IDs, the location where this VLAN is in use. Perhaps it belongs to a VLAN group. And of course, we can always name VLANs, so here we can model those as well. And if this particular VLAN is participating in a network, then we can assign that prefix that is used on the VLAN, the tenant concept, of course, the status, the role, and the description, all fields that you're familiar with from the previous sections. So that covers our basics of a VLAN. Now let's drill a little deeper into the VLAN group. So here we can see this particular VLAN is not assigned to a VLAN group, but what VLAN groups allow us to do is to enforce uniqueness within our VLANs and the way they're assigned. So we can have VLAN groups being assigned to locations, but not to multiple locations. So a VLAN group is unique to a particular location, and within that group, those VLANs will then become unique. This allows us to model the scenario where we have, let's say, our primary data center A, and our secondary data center B. And perhaps we're using the same VLANs in both data center A and data center B. Now we can say, hey, this VLAN group belongs to data center A, and then this other VLAN group belongs to data center B. And now we can have those overlapping VLANs modeled within Nautobot. VLANs in the same group must have a unique ID and name. So this is a key concept to understand because we are specifying them within a group. VLANs not associated with a group do not have this restriction. So it's only when you put them into a group that you must be unique ID and name. So let's take a look at creating a VLAN group. Since we don't have any here in the demo environment to get started, let's add one. So we're going to go in and we're going to add a new VLAN, perhaps out in, let's say, our Amsterdam site. So we can use the easy search functionality of Nautobot to quickly drill to that particular site, Amsterdam 01. And we're going to create a new VLAN group, and let's just call it Secure POS VLANs. And our description will be our POS devices. And we're going to go ahead and create that group. So now we have our POS VLANs group created and attached to the site of Amsterdam. So now within this group, we'd love to create a VLAN so that we can actually start to use it, our point of sale VLAN. So let's go ahead and add a VLAN. So now we're going to come in, we're going to add a new VLAN. Let's just call it VLAN 57, for example. We've got our point of sale devices. And our status is going to be active because we're actually going to turn this up, and we're going to assign it out to that VLAN group that we just created. Go ahead and create that VLAN, and we can see now assigned into that group. So if we were now drill into that VLAN group, we see VLAN ID 57 now attached to this particular group. And we can go back, of course, through the UI back into VLAN 57. Here we go. Okay, so that covered attaching a VLAN to a VLAN group and their use and functionality within the IPAM section of Nautobot. So in summary, IPAM data, along with device and organization data, will serve to define your intent and inform your automations. Automations will now know which IP addresses and drivers to use to connect to your devices. This concludes our second hands-on guided sandbox video in the Nautobot Navigator series. I hope you learned something new, and I'm so excited to dive into our next guided video, which will cover some deeper topics around Nautobot's network source of truth functionality. Thanks for watching, and happy navigating.